answering problem what from web work?
8 and 9.
This is problem 8 from web work. Dear viewer, wherever you might be some of us. And then what about a constant? So like if this were a 5, where would it go when I take the antiderivative? It would go to 5x. So this is weird. It's a constant, so it actually would go to what? Cx. And then I have to add on another constant because I just integrated again. So plus d. So now, Kinter, what I'm going to do is now plug these values into that function. This is like one of those problems I put on that I want people to ask. Thank you. And everyone else is like, oh, shit, thank you. Because this was one of the ones that lots of people were leaving blank even when they got it. So now let's incorporate these conditions into that, and it's going to give us some stuff about C and D. So first off, when we have this f of 0 equals 7, that means when x equals 0, the f of x equals 7, right? So this is my x, and then the output from the function would be 7. So when x equals 0, I've got 1/2 0 squared minus sine of 0 plus c times 0 plus d. Something wrong?
Would it be 3 halves?
It would, thank you. Good Lord, I forgot it. Thanks, because of the 3 that was there. Yes, thank you. 3 halves. Luckily, that didn't mess that up. But. So notice how I'm taking the antiderivative twice, adding on constants of integration each time, and then taking that final function and plugging these values in. So look at what I get. What does that tell me? What's sine of 0?
Isn't it 0?
It is 0. So this is 0. So that's dead. That's dead. That's dead. So d equals 7. Plug that in. Then, so I know d equals 7. Now let's put in x equals pi over 2. And this is going to be, oh my God. Okay, it's not going to be pretty. So I plug that into the top function, and that's going to be 3/2 times pi over 2 squared minus sine of pi over 2 plus c times pi over 2 plus 7, because I now know d. And that is supposed to equal -1. So now I solve this for c and I'm done. And not that that's a trivial thing. Let's actually finish it here so we can all, you can see that I'm not afraid of this. You shouldn't be afraid. Just take your time, read deeply. So this looks like it could be beastly. One thing I would recommend, please don't go to your calculator, because you're probably going to lose precision and you're going to enter it into web work, and web work is going to say no. So I would do everything exactly. So this becomes 3 pi squared over 8, because 2 squared is 4 times 2 is 8. Kitcher, we're talking about what's sine of pi over 2? Josh, which one? Yeah, is it 1? It is solid. Nice. Josh saves the day. Some trig knowledge. Beautiful, sir. So sine of pi over 2 is 1. Plus c times pi over 2 plus 7 equals -1, and then, keep on cruising. It ain't going to be pretty. Let me get a couch. That's reclining. So this -1 and that -1 would cancel. Really what I want to do is I'm going to leave c times pi over 2 on the left and get everything else to the right. So that and that'll cancel. I'll get -7 minus 3 pi squared over 8. Multiply by 2 over pi. And I would just leave it like that. So that is not attractive. That is pretty rough. But what I would do is then write the final equation out. So it would look like this. So WebWorks going to ask for your final function. And let me show you how I would enter it, Lou, just so you can kind of see, get a sense of the way this would roll. So in WebWork, I would say 3 halves x squared minus sine of x. And then this is still in the same line, but it's going to be pretty atrocious. Plus, I'm going to put that freaking thing in. 2 over, how do we do pi? Do we just write the word pi?
Mm-hmm.
Yeah, in capitals or?
Doesn't matter.
It doesn't matter, cool. So let's use lowercase, that's easier. 2 pi, and then put a parenthesis, -7 minus 3 pi squared over 8. And it'll understand the order of operations here. If you feel like worried about it, put parentheses around that, but that's totally PEMDAS okay. And then times x, and then plus d, which was 7. It ain't pretty, but this is our life. If this is the worst problem in our life, how good is our life, right? The worst problem in our life, our life is entering things into WebWork. We're kind of blessed. We're here in a nice room. We're all wearing clothes. It's more or less the right temperature. We're doing math. There's about 1 billion other people who would give anything to be here right now. So that's ugly, but it's not so bad. So Kitcher, does that help?
Yeah, definitely.
Yeah. What was number 8?
Number 8, like the problem?
Or was it similar, or was it? Yeah, because you'd said 2 problems, right?
Oh, number 9 is exactly the same.
Oh, okay. Is it?
It's just with sine instead of cosine, but yeah.
Weird. That's weird. Well, that's bad on me. That's bad on me. Yeah.
What's the reasoning behind you using the f of 0 equals 7 as the c rather than the d?
Because so the original function looked like we worked our way up. It looked like this, Kelby.
Mm-hmm.
Right? So when I plug in 0, it literally kills off that C,
Okay.
and it just leaves D.
Okay.
Dead. D, it must be 7.
Okay.
Is that, yeah? Other questions?
Just like for my own e, the top, the e to 0 is 1, right?
Correct.
Okay.
Everything to the 0 is 1 except 0. We will get into that. 0 to the 0 can be anything. True. Pretty weird, but true. Oh, the wonders of math. Here's another one we'll actually talk about. That's not 1. That can be anything too. In fact, it's quite often equal to e, which is weird. Yeah, let's not get there yet. Other questions? Things to discuss. So when does that assignment due?
It's 30, I think.
This is Thursday. Is it tomorrow?
I think it's Monday.
Okay, good. That's good. Tomorrow's too soon. So, lots of time to ask. We got Friday still to ask questions and talk about this and get involved. It's a good warm up. Okay, so we're good on that web work. Let's knock that out. And then on Friday, I will give a new web work. Because this is the review web work from Calculated. It's like, maybe we'll be doing some new stuff. I hope so. Maybe not. It's okay. I'm all about just doing what we need to do. Last time, you were here for my exposition of Riemann sums. What you got out of that could be quite variable. Could be like tired, probably tired, a little bit tired. Yeah. A little tired, that's okay. I want to give you just a quick recap, but using computers to help show the idea. So the idea of integration is this. I've got this nice parabola. Here, let me zoom in. So I've got lovely y equals x squared. And I want to find the area between 0, oh here, let's do, we actually, did we do this by hand last time? Cool. So I want to find the area under that curve. Ooh, look at that. That's nice. Am I at 1? Let me get right at 1. There we go. Beautiful. So that little wedge right there, I want to find the area underneath there. So what I do is I cut it up into a bunch of rectangles. Right now, we have just one rectangle, and it's using the left endpoint for the height. So I only have one interval, the worst estimate possible. And it's saying, well, this function starts out as 0, so it's probably 0 all the way across, and there's no area. You know, look, it's giving me my answer. Riemann sum, this 0.01, because it's kind of off just a little bit because it's a computer. So we add more rectangles. So now I've got, how many rectangles there? What is that, 2? Yeah, so now I've got 2 rectangles. What is it? What the fuck is it using for endpoints? That's the weird thing. Oh, here. That's the problem. That was off a little bit. So now I've got 2 rectangles. First rectangle has height 0. Second rectangle starts halfway through, and it's got height 1/4, because that's 1/2 squared. And so it's giving me that estimate of the area up there as 0.125, 1/8. So we add more rectangles, and we get a better answer. So watch this. As I start to increase the rectangles, and we're always using the left end for the height of the rectangle, look at how, watch the area. See how the area is starting to increase? It's kind of increasing there. But now check this out. The first 2 decimal places of the area are now fairly constant. They're not moving much. And then that second one moves, but that first one is still 0.3. Now I'm up to 52 rectangles. And I keep on cruising. And look at that, we're up to the 70s. There's 80 rectangles. Now, that's giving me an approximate area of 0.3271. Didn't I crank this out exactly for us at the end? The true answer is 1/3. So the true answer turned out to be 1/3. We'll prove that in just a minute with calculus. But check this out. I can also use any point I want. So we were just using the left side, but remember remember the x star that was any point inside the intervals? So that's what this little button lets me do. It lets me pick different places to determine the height. This one's just using the middle. So the value right in the middle of the interval is where we determine the height. Let's see if that helps a little bit. Let's crank up. Look at how the area is actually more accurate now. Because 1/3 is the truth. That's a lot closer to 1/3. So depending on where we pick that point, we might get a more accurate representation if we're just, if a computer has to do the work for us, then we want the most accurate thing we can have. And sometimes using that central point is better. It's not always the case. Let's pick a different function here real quick. I can put any function I want in here. I like being a sine. And I kind of want, why is it not doing that? Maybe I gotta hit enter? Oh, yeah. Let's find the area under the sine curve. Just that first little bump. Okay, right there. So, oh, look at that. That's actually a pretty good representation right now. We've got a hell of a lot of rectangles in there. This thing won't let me do more, which is kind of shitty. Let's get the true area. So, using those rectangles, we did pretty good. But anytime you want precision, you're going to want to use calculus. If we want the exact answer, we're going to have to use the methods of calculus. Otherwise, we're just getting approximations. So, I just wanted to refresh the idea of lots of rectangles giving us approximate areas, and we're going to drop that for a while. We're going to come back to it in a bit, so that's the end of that. All right, so let's get with it. Okay, good Lord, where are we going with this? Okay. So, fundamental theorem of calculus, let's just start there again. FTC, and this was part 2. Josh, would you do me a favor, please, and just make sure I'm recording?
Yeah.
Thank you so much. Cool. Yeah, because John will have to watch it afterwards. You got your headphones on, are you listening still?
No. Oh, yeah. No, I'm not listening to anything. I just haven't heard.
Okay, all right, good, all right. So, fundamental theorem of calculus says that if I want to do this, need help, got it? Did we actually talk about this last time? Did I put this up on the board? Okay, beautiful. And what was this big F? What did that represent? Antiderivative. So f of x, big F, is an antiderivative. Why do I say an antiderivative?
Because there's multiple.
Beautiful, right? That's what the plus C is all about, because there's lots of different ones. There's infinitely many. Antiderivative of little f of x, i.e., if I take the derivative of that thing, I get the integrand over here. And this, so all I want you to know about that whole last class is that this is a collection of symbols representing that insane process of infinite rectangles. That's what this represents, that whole process. That's why this is outstanding. Instead of that, I can just use this. So if I want to find the area, let's just pick that up again, under x squared between 0 and 1, that, hold on. So I learned this on TikTok. WD-40. What? That's bullshit. Man, that is, I want my money back in this hardware. But check this out. Now, Danielle is like gonna be leaving here smelling of lighter fluid or something like that. But we're just making this shit more and more flammable. But look at that. I had. Now I'm in the trash. I'm kind of like a hobo. Oh wow. Oh wow. That is. It's disturbing to see a grown man get this excited about this. Okay, so if I want to find, but
Looks great.
It's so clean.
it's freaking amazing.
Yeah.
It's amazing. It's like the only way TikTok has enhanced my life ever. That one video by that weird dude doing that. So I want to find that. And that, oh, I just fucked it up. But that is the old y equals x squared parabola from 0 to 1, and I'm trying to find that area underneath there. So to do that, I have to take the antiderivative of x squared, which, let's make a little table to refresh our memory about antiderivatives. So if here's f of x, here's antiderivative. First one is if I have x to the nth power, and this is n is not equal to -1. When n is -1, that's 1 over x. That's a very special rule. So don't touch it, you just WD-40'd it. I'm talking to myself, as usual. So the rule is add 1 to the exponent, divide by the new exponent. But I just multiply by the reciprocal. I think that's an easier way to say it. That'll make more sense as we move along. If I have x to the negative first, which is 1 over x, what is that? What's its antiderivative?
Natural log x.
So solid, beautiful. And so we can even put absolute value of x, that's cool. Natural log of x, natural log absolute value of x, kosher, pretty much always good. Now, there's like plus c's on all that shit. I'm not gonna write it, it sounds exhausting. Let's put some others up here. We've got cosine of x, what's its antiderivative?
Sine.
Thank you. What's the antiderivative of sine of x?
Negative cosine.
Oh, I love it. Oh, yes. Yes. Okay. Yeah.
CDX.
It's just e to the x, the best one in the world. Doesn't change on integration or differentiation. That's plenty. We can do a lot with that. So let's leave that up. We'll just stay that right now. And then you get a table out, there's weird stuff like this. Let's just do a quick little Jeopardy. What is what is the antiderivative?
Secant x.
Secant, beautiful, beautiful. Secant of x, love that, awesome. And then weirder, things become weirder and stranger and just, that's what we have tables for. So, here I have the first rule. I've got x to a power, so I take the antiderivative, add 1 to the exponent, divide by the new exponent, multiply by its reciprocal. And then evaluate from 0 to 1. Now, I should have wrote out what this meant. This meant plug in the upper limit, plug in the lower limit, and subtract. And that's what I'm going to do over here. So this is 1/3 times 0 times 1 cubed minus 1/3 times 0 cubed. And that's a beautiful, perfect 1/3. So, this is where we begin today. Let's do a quick review of a couple of these. Could you please, all right, hold on. I think we'll have a brief quiz. We're gonna have a little quiz on Monday. A little quiz, just a picture quiz. If you've been with me, you've had this picture quiz before. Quick quiz, if I remember. And people are probably laughing because I never remember to actually do these quizzes. So there's hope. Monday. I've got a stash of sweet black pens, but I forgot them. So Monday quiz. Without notes, produce the graphs. Yep. Of y equals sine of x and y equals cosine of x. Beautiful graphs of these. Wait, your shitty graphs left and right, right? Like here. Now here's my sine. That's also my cosine. Done. No. Let's do sine. Here's what I want. And I just want you to know one period's worth, because once you know that, you own the entire thing. So if you came from a place where calculators are what we use to manipulate life, this might be a little shocking, but you need to know this. And knowing this makes you powerful. So 2 pi is the full period of a basic sine of x. 1 and minus 1 are the maximum and minimum amplitudes. Label that 2 pi, cut it in half, that's pi. Cut that in half, that's pi halves. What's between these two? What's right in the middle? 3 pi over 2. If that baffles you, if you're like, how do I know that? Take the pi off. Here's 2, here's 1, here's a half, and here's 3 halves, right? It's just tack on a pi, it's all good. So sine starts at 0, low point, high point, right at pi over 2, midpoint, low point, right 3/4 of the way through, and then comes back full circle, literally. Now that is a beautiful graph. If I saw that, I would swoon, and I would give you perfect credit. Because that's just lovely. So that's sine. So now, when I ask you, what's the sine of 3 pi over 2? You have this in your head. What is the sine of 3 pi over 2? Negative 1's right there, right? That's why knowing these gets you far. You've got it. What is the sine of 3 pi?
0.
Where's 3 pi? So imagine this continuing, right? So you got it. Yeah. So 3 pi is just another one of these. So there's 3 pi, so you know it's at 0. In fact, you could actually tell that sine of any multiple of pi is going to be 0 from this. Yeah. And I could get trickier, but I'm not going to do that. So that's all beauty. Let's do cos. Cos start out the same. That's a little askew. So 1 minus 1. Make yourself a box. Same box, cut it in half, cut it in quarters. Pi halves. Thrice pi halves. Cosine starts at its high point. 0, quarter of the way through, low point halfway, 3/4 of the way back at 0, got that. Hey, let me ask you something, especially if you've had class with me before. Do I like this? Is that cool? Is that a cosine graph? No, that is not a beautiful cosine graph. That is called a triangle wave. And it sounds, did we ever listen to them in class? Yeah, so like if these are waveforms, I'm not gonna get it out now, but if you listen to them, you're like, okay. No, I won't make you listen to it, but it's like a buzzing sound. Like this is like a, and this is like a, beautiful. Beautiful tone. So that's your cosine graph. Monday. Know those by heart. How do you practice them? You practice them. Sit down and go, what do they look like? Did I do it? No, do it again. What's the cosine of 4,000 pi? Wait, what'd you say, Josh? Wait, oh no, one. That's a better answer. Because even, check it out, every 2 pi it's 1. So 4,000 pi. Yeah? What about 4,001 pi?
0?
Negative 1.
Negative 1. That's good. Because that's the odd multiples of pi.
Oh, right.
Yeah. Cool. So that I don't ask you to do stuff because I get jollies out of having you like just do things. I think that they're powerful and important things that will help you become stronger in your career and in this class. Okay, so now I can actually ask, that wasn't even the question I wanted to ask. I need a new pen. Sorry, Olivia. I'm a little punchy this time of day. If I ever hit you with a pen, I will like have to kill myself because I would feel so bad. So I hope that.
I failed calc.
What's that?
I said then I failed calc, so don't do that.
Okay. No, I think. Oh wait, no, I shouldn't say everybody gets an A. That's like a big target on my back. No. They'll bring somebody else in, and it'll probably be a different show. So let's do this one. Let's find the area, like we did on the computer, under this first hump of sine. So in other words, the integral from 0 to pi of sine of x bx. Can you do that for me, please? All the information you need is here. I'm going to put a little reminder on my phone. That's right, I'm not going to forget that quiz. Starts at 2 p.m. We heard a very confident pencil drop. I like it. Right, we got that up there. Don't forget to use parentheses and the double negatives that are going to occur in this one. On that second, sure. On that second one, that's probably pretty, yeah. Is this making sense? What's up here? Yeah? Okay. So, here's a couple words of wisdom, perhaps. Use notation. Notation exists to make it easier on your mind. As I think I said this on Monday, notation is technology. Writing is technology, right? I mean, look at what happened to civilizations when they develop writing. That's when things explode, when we have a way to communicate. We're communicating. You want to communicate with your brain. Help your hands and your brain work together. I will make you write this stuff. I'm going to have you write some stuff probably next week. So Cal can turn it in because I want you to write this stuff. So I'm keeping track of everything. If you just like go from there to the answer of 2, I don't know if I believe it. So this is negative cosine of pi. I pull out my graph. That's -1. Beautiful. Minus negative cosine of 0. That's 1. Beautiful. That's 1 plus 1. Oh, good Lord. How can the area under sine be 2? How can it be whole? I don't know. But I love it. I love that it's whole. Okay. All right. Questions? Because I'm going to hit the ignition switch in just a second here. We're about to lift off into Calc 2. Still in Calc 1. Okay. Okay. And so your assignment that you're working on is kind of a lot of this stuff. What if the problem were instead now we're in Calc 2 territory. I'm in Calc 2 territory because I don't have a table that says sine of 2x has an antiderivative of such. All I know is that the antiderivative of sine of 1x is negative cosine of. That's the only thing this table tells me. I'm going to make this table look a little bit different by replacing all the x's with just a different letter. And I'm going to use u's. So instead of u to the n, it's u to the n plus 1. Let's just replace all these with u's. Because that x makes us think that these rhythms are restricted. And I think the table, I put an integral table up on world class, and I think it's in use. I hope it is. If it's not, I need to get you a U table. Even though it's the same thing as X, it doesn't matter. These are rhythms. These are just rhythms of how to manipulate. But it's nice with that U, because now I look at this and I think, man, I don't have that, but what if this were just U in here? Okay, now I can do that because I got a table. Table helps me do that. So I'm actually going to rewrite the problem. This is called substitution, integration by substitution. So we make this look like the table formula. That's the game. Sometimes that game can be very tricky. So here's kind of some of the art and science of Calc 2 and doing this whole class, is you look at these patterns, and here's the pattern that I know. So the table formula looks like this. Antiderivative of sine of u, du, those should all be du's if I didn't, there's none up there, so that's cool, is negative cosine of u. This u is a box, so think of it like this. Here's another way to think of it. Sine of something, d something, is equal to, stupid plus c, negative cosine of something plus c. So I like to think of these formulas as transparencies. And I lay them over. I look at what I think I've got, I lay it over that formula and look at what comes through the u. What is in that spot? And what is in that spot here? What u value would make this look like this? So to turn this into this, what do I need? 2x, right? So lay this over the top. Take this pattern, lay it over the top. What comes through the window? 2x. So I'm going to say let u equal 2x. Did we get here in my Calc 1 class?
Yeah.
Okay, cool, good. Other folks in your Calc class, did you get to this? Been here? Okay, awesome. Some haven't, but most have. So I'll kind of describe it in a couple different ways. That's great to know. It means we can move along. So you make this choice, and then you have to find the differential change. So step one is decide what u is. And that is by knowing the patterns that we understand and looking at what you have and catching the rhythm. Step two is find the differential change. That sounds very fancy, but it's really what we're doing this for. So the differential change here just means take the derivative of both sides. So like this thing here, step two, derivative of, actually, the u will always just become du. Think of it as derivative of u, but it's really differential u. Equals, what's the derivative of 2x?
2.
Thank you, I was about to fall over. 2, and then the x that I tack on a dx. So I'm kind of just tacking that on there. Step 3, solve for dx in terms of du. So here's where algebra comes in handy. Just divide. Here it's easy. Here I just have dx equals 1/2 du. And then step 4 is where the magic starts to unravel. Unravel. I don't know if something good's happening. It's not something bad, that's for sure. So step 4, is make the substitution. So check this out. There's going to be a couple things. Notice how we have limits on this one. I'm going to hold off for a second. So I've got integral sine of 2x. The 2x is now u. That's what I was shooting for. I want it to look like this. If it's not looking like this, I'm very confused about what I'm doing. If it doesn't look like the formula I chose, I got lost along the way. So now this becomes this, and now I replace the dx with 1/2 du. And it's kind of like, it's the same thing. Don't freak out, because I can pull this 1/2 out in front and will. Any constants can come out in front. It's okay. Let's adjust the limits. So there's a couple of ways to proceed here. Some people teach this where do this and then use the formula, then back substitute, and there's a lot of error that can happen there. So when you have these definite integrals, I'm going to recommend this route. You can take whatever route you want, but this is the route I'm teaching. Make the substitution. We're going to change the limits of integration using our substitution. So the substitution was u equals 2x. So our original limit, our lower limit was 0. So when x equals 0, remember this is our lower limit, u is equal to 2 times 0, because I'm just plugging it in here. What is u when x is 0? And that's still 0. So this is my new lower limit. This is the old lower limit. This is the new lower limit. When x equals pi, u equals 2 pi. That's my new upper limit. That's my new upper limit. I'll get out of your way. Maybe Daniela. New upper limit. Rewrite the integral. So step 5, well, this could still be part of step 4, I guess. So our integral is going to look like this. Oh, it's right here. It's right here. I'm going to plug the limits in. So my new lower limit is 0, and my new upper limit is 2 pi. And then there'll almost always be some constant here. Not always, but most of the time. That's why you did this. So you bring that constant out in front. Step 5 is use the formula. Evaluate using the formula. And so what that's going to look like is this. 1/2, take the antiderivative. So this constant rides along. Antiderivative of sine is negative cosine. And I'm using u. Look, I'm not going back to x. That's a u integral. So I'm sticking with u. Sorry, it's a little hard to see because I didn't get to WD-40 this part of the board. So that is 1/2 times negative cosine evaluated from 0 to twice pi. Plug in the limits. So that's negative 1/2 cos 2 pi minus, because that's minus there, I gotta be careful. So negative 1/2 cos 0. And then crank it out. So cos of 2 pi is 1. That's plus 1/2. Cos of 0 is 1. And I've got a net effect of 0. So while you get caught up, I'll sketch the graph of that so you can see what happened here. Why is that 0? So here's the graph of sine of 2x. It actually has its period is half of the normal sine, so it's going faster. It's oscillating faster. So this is sine of 2x. And what we did was we integrated from here to here. Why is the answer 0?
Square the
Bob, say that again. Who said that?
Where the lines
Oh,
at?
sorry.
Is that it?
Can you explain more what you mean?
Where it intersects?
It's definitely there. It intersects at 0, but remember, so bring this all back to area. So bring this back. So this is the area between this curve and the x-axis from 0 to pi. So it's this area plus this area.
1 minus 1 equals 0.
Yeah, exactly. So these two cancel each other out. That's what happens. This area is equal to this area. That's what happened in the end. And that's why the answer turned out to be 0, because the size of this is the size of this. They're just opposite sign. Let's play some more. Any questions? Well, let me stop for a second. I'm just like on, maniac mode. Does any of this need clarification? All right. Let me give you some problems. Yep. So I'm gonna put a couple up here, and I'm gonna ask you to just work the rest of the time. And I'll come around and help, and I'll put the answers up. And let's do some problems together. So first problem, 1. Integral from 0 to 1, super friendly. E to the 3x dx. Is that okay, Fernando? Is that hard to see?
Kind of blurry, like the glare of the window.
You mean the glare of WD-40, Fernanda? Is that what you're trying to tell me? Olivia, could you twist that, please? Just that upper thing. Let's see if that'll help. Yeah. Awesome. Cool. Thank you so much. So, integral from 0 to 1, e to the 3x dx. Integral from 1 to e, and this one's not going to be super tricky, but test your log knowledge, or at least refresh it briefly. That's 2. 3 is integral of x plus 2, 1 over dx, from 1 to 3. And then we'll do one more. Leave some space here. 4. Integral minus 1 to 2. Use substitution on all of them. You don't have to on that last one, but please try to use substitution on it. And I'm gonna shut up now. That's good. I'll walk around, help you out. This is kind of more like how class will normally go, rhythm. I talk for a while, we do lots of stuff together. Hey, good. A friend to talk to. Yes, ma'am.
Last year, I just wanted to do it a little different. I don't know what it is. I don't really remember the ones last year. Was there like another way that?
So there is another way, but it involves first doing this, then back substituting and put it in. Oh, we did talk about this.
I
But-
think you should just both, but I think I did the other way.
I would like you to try those limit changes, please. That's a very powerful and important skill, for sure. Josh? You wrote Joshua on here, but you prefer Josh?
Yeah.
Okay.
Yeah, either one.
Either way, it'll work either way?
Either
All right,
way.
okay, cool. Vivian, okay. Yes, okay, that's right. Oh my gosh, yeah. That's right, that's right. Oh, it's on, it says right here, thanks, Vivian. That was a long time ago, Vivian. It feels like, I don't know when that was. Maybe it was just like last year, but it feels like a billion years ago. If you need anything, just pop a hand. Yep, just like that. Come around this way. Oh, you're good. You're fine. Yeah.
So for example, I'm gonna ask, do you want to go in and use your substitution? Can I just do that? Because that is a rule.
Yeah, it is.
And then for this one, is now just one.
Yeah, that's a nice shorthand rule. Yeah, that's cool.
Okay.
Absolutely.
But
But,
E is one correctly.
But the answer to this, yeah, that's actually right. Yes, so L, so the answer to the simplified.
Also, because E to the power of anything gives me confusion. But,
So
yeah,
the cool,
I
so
guess
the good news is just leave it as E to a power unless it's 0, and then make it 1.
Yeah, so it's just this minus 1/3, but like,
Yep.
I don't wanna have to figure that out anymore, so it's not there.
That's cool. You've already figured it out if you know that. But,
And then L and E is correct, it's just one correct.
Correct.
Because of inverse.
That's
So
right.
can I also just leave this as one?
No,
minus
I want you to,
one?
so like on an exam or homework or something like that, I'm gonna ask you to simplify. So I want you to know, I want you to write that out, because it's a beautiful answer. Like right now, it's ugly, right? What's the final
Would
answer?
I be able to just have it be 1 minus L and 1, or do you want me to give it?
What's L under 1? That's 0. So that's what I want you to put, that's 0. So the answer's beautiful.
The other things like that with E to the power of anything, LNs, except for stuff you trig.
So, oh, so not L under 0, but just 0. Yep. Cool. And then 1 is your final answer.
That should be it.
Cool, okay. You good, Isabella?
Yeah.
Okay, awesome. Okay, cool. Cool. Let me go get Josh, and then I'll be right back. He had his hand up.
You want us to substitute on number 2?
Actually, number 2 does not require substitution, so good call, Josh. Yeah, it was a little bit of a trick. Yes, ma'am.
So, there's probably, X equals 0, E times 0.
Perfect. Yep.
And then 0.
Yes. Doing good, David? Yeah. Awesome. Luke, you good? Yeah. Do you want me to look at some? Kind of feel like you might, I'm not sure. Okay, you just do it. Okay. Okay, let me help with that. Yeah, you're not the only one. Natural log, there's only 2 values of natural log any human needs to know. Here's natural log. There is natural log of 1, which is 0. So I want you to know these, and I want you to use them. And the natural log of E is 1. So that's out here. That should help you with number 2. And it's a natural log. Ladies, everything going good back here? Yeah? Okay, cool. How about you doing good?
Good.
Rocking it? All right. good, Andy? Yeah, okay, yeah, okay. Totally. Let me set this down so I don't dump it on your head accidentally, something weird like that. So that's one, right? So it could just be, it could be, I don't like that.
Yeah.
But that's okay, that's for you, not for me. This is for me. So that's beautiful. That's beautiful. Oh, Lord, I can't look at that. But yes, that's lovely. And then, got it, I guess. I just made it up, so I don't know. That sounds about right.
Okay.
Yeah. Cassie, how's it going? Yeah? That's.
It's been a while since I've done
Yes,
calculus,
so this is backwards. You're subtracting backwards. I'm glad I checked. So it's the top minus the bottom. So just keep that in mind. Yep. Vivian, are you doing okay? Or rocking it? You simplifying it. Oh, your simplifications make me so happy. Good Lord. Yep. Sorry, I don't know why I erased that. Yes, Lou.
I did this correctly, but I just include extra.
That's beautiful, but change your limits as well. So, yeah, so your new limit when x was 1, you will be 1 plus 2.
Oh, okay.
So then 3, does that make sense? Your new lower limit's 3? Yeah. Yep. Start working these through. If you ever are like, I want to tutor, let me know. I know a couple good ones that are working in the tutoring center. That's all free at Regis, so don't hesitate to reach out. And there's actually a retired math professor working over there. She knows her stuff. Right, I did. Slow down, buddy. That kind of needs some love too. That's awesome. Then the other two are pretty gassy. Ish. This one's that one's something else. What was the number you got on number 4, Kitra?
59 thirds.
59 thirds. We'll find out in a bit. That sounds terrible enough to be right.
should be 63.
60,
3,
oh, just clean?
I think.
No, I got 21 clean.
21. What am I doing?
You had 60 for every three?
Yeah.
So 21.
Okay, yeah.
You got 21, really?
Yeah.
I
On my
forgot.
second.
I forgot a number.
Stupid.
No, I don't, well, no, you're not.
Oh, I thought you were gonna be like, well.
No, I'm freaking amazed. I made up that problem and it turned out to be nice.
That's it, yeah.
Yeah.
Hopefully-
Something's a force
I
driving me.
forgot what number. Thank you.
Yeah, it
It's
is.
like, wait.
Truly is a higher
One
power.
second.
I'm gonna make one, on number 3, I'm gonna make one last tweak. This is totally cool. Like if you have that, that's so happy making. But it could be put together like that using log properties. Just a single thing, log of 5/3. Oh God, okay. I didn't make any nasty differential changes on this one, so. That's a negative practice, though. I can't believe that's 21. I can't wait to see it. Oh yeah, it will be. Wow. That's so cool. Good old me. Oh my God, yeah. I'm in love with that answer. Oh. Whew. Danielle, how you doing? You feeling okay about this? Yeah. Yeah, nice writing. John, you good? Spelling? All right. We're good? Good. Awesome. Awesome. Yeah, you're good. Once you adjusted that tiny little
Yeah.
tweak on top, and we're good. Yeah. Yeah, good. Yeah, we're good. Yes. Yes. Yeah. Okay. Lots of hearts, lots of love. Feels like, how long we've been, is it like 3rd month of school already? Something like that? Like that feels like it today. I talk for like, I talk from 12:30 to whenever we're done, which is now. So we'll wrap it up. Well, get out early. I'll hang out here with anybody who wants to hang out and finish up. So let's see, what do we have on our plates? We need to make sure if you haven't logged into WebWork, you want to log in and try a problem. Please, God, do that. Did I talk about how I hate to be a cop? Have I talked about that in here? Okay. Don't make me be a cop. The only time we'll ever have trouble is if you make me be a cop. Because I fucking hate it so bad. I don't want to be an authority figure. I was thrust into this by, I guess, my life choices. All right, dear friends. Friday, we meet on Friday. Less time. It's brisk and lively. look at it real quick? I just got it. Okay, so that's, yeah, so that was the right movie. So, yeah, so you still need to convert that to a half pound. So that becomes, so, oh, thank you, cool. So, thank you, thanks. So this I would rewrite as, and I would pull that 3.5 out in front. Du, like that. And so now it's a lot more, now it's actually ready to roll with the power rule. So on this one, just add 1. So you're in that form, it's not u to the negative first, so all's good. So add 1 to the exponent. So what's negative 5/4 plus 1? Beautiful. Yeah. So it's u to the negative 1/4. And then I multiply by the reciprocal of that, which is just negative 4. Yeah, sorry, I'm telling you, and you're like getting it. But that, like that. And then plus 3.5, what's this one going to go to? Yeah, so you have 3 halves, and then what do I put out in front? 2. Yeah, it's just flip that beast. Yeah, so oh, what did I do? I did something weird. Yeah. So 2/3. So that's kind of weird. So that'll be 7/3 that actually turns into, right? So and then back substitute. Oh wait, is this just the problem? It was just like this. So yeah, so that's it. So that's just 7/3 u to the 3 halves. This guy. It is. Are you cool with like how you would enter that? So let's talk really quick here about that u to the negative 1/4. In web work, you're going to go.
Probably didn't put the friends.
That would, yeah, that sounds like a really common mistake. Yeah, and if you're doing web work and you start doing it if you're like on your 6th try and you don't know what's going wrong, just send me an email and have me look at it. Happy to look at it. You got it. Cassie, would you stop that for me, please?